So my project is on characterizing the properties of lubricant gear interactions and mitigating failures of gearbox in the wind turbine system. Um, so I'm actually from the University of Prince Edward Island, and my supervisor is Dr. Initial. Um, so the picture I have on the left is about the wind turbine system. And you know that the wind turbine system actually works with the blade converting the energy of the wind to electricity. And then we have major components that actually causes. How do I press this one?
Just need to have the right way.
Oh, okay. No, that's fine. So the wind turbine system actually, like I said earlier, has to do with the blade that converts the energy of the wind to electricity. And then we have major components as the gearbox, the generator, the yaw, and the drivetrain. These are the physical components that actually causes downtime. And my project is on working on how can I actually improve the performance of the lubricants and also the materials used in the gearbox. Sorry. So for the common gearbox failures, I put out 4, where white edge crack, pitting, and fatigue. Funny enough, we learned about some of them during this training. So for the wear has to do with the gradual removal of the material from the surface, and white edge crack, this has to do with the microstructural degradation, and then we see white areas on the microstructure when we etch with the etchant, and then micro pitting, happens as a result of small pits that occurs on the surface of the material, and fatigue, which we already know about, that happens as a result of repeated cyclic loading. So these are the common failures of the wind turbine gearbox. So I'm looking at how can we improve the system, how can these failures be reduced. And for my mobility, I'll be going to Yolanda's lab, and then I'm currently learning about the various characterization equipment that are available at the Surface Science Center at Western University. And I'm looking at spending 3 to 6 months there. And the next slide will be on the equipment. There are a lot that I'm looking at. So what I did was I went through the website, looked at the equipment and the ones that are relevant to my research. So the ones on the green are the ones that I'm most likely going to work on. I'm actually going to work on, and the ones on yellow are the ones that I may work on. So I'm looking at working on the scanning electron microscope, the optical microscope, hardness testing for the gearbox material, contact angle of the lubricants to check the workability. Also look at using the conical laser scanning microscope to check the wear surface to see how much wear would occur as a result of the test. And then, sorry, I keep going back. Okay, and then some other equipment that I also highlighted. So I'm actually looking forward to the opportunity to work in Yolanda's lab. And from my research, I'm already currently working on CRTE simulation of the gear lubricant interaction. So for my simulation, I'm using ANSYS Fluent, working on simulating the lubricant interaction, simulating the losses that happen as a result of the gears interacting with different lubricants. So for my simulation, I'm looking at different lubricants that are currently being used in the wind turbine gearbox system. I'm also looking at the effect of temperature. How does different temperature actually affect the performance of this lubricant? And then I'll be quantifying the losses, calculating the shunning losses and the likes. And I have a small video of the simulation. Yeah. Thank you. Questions, comments?